Oh, good. We've got people logging in. All right. We're going to give it just a second and let people
Sure.
log in.
Okay.
The good news is that this is being recorded. I know there's a lot of people that are trying to finish a few projects in before Thanksgiving break next week.
I know, right? It's coming so fast.
I know. So it's good. It's great that we're going to record this and we'll share it with everybody afterwards. And there'll be an email go out tomorrow with the link to anybody who wasn't able to attend live today.
Great.
And then to the rest of our list of friends of Builder Partnerships. All right, we're going to go ahead and get started. Okay, good morning, everyone. Thank you so much for joining us on Webinar Wednesday. We are very excited to have David here again with us today from Fox Blocks. He's going to be talking about resiliency and sustainability and building for the future. I did get a preview of some of his presentation, and it's going to be very exciting. Lots of great information, so make sure you stay tuned. Have pen and paper available so you can take notes as well. Before we get started, though, I do want to go through a couple of housekeeping items. Down below at the bottom of your screen, you will see two little chat bubbles with the letters Q&A underneath that. If you have questions at any point during the webinar, please go ahead and take advantage of asking your questions in that section. I will reserve all the questions until the end and read them out loud so that David can answer them for you. But I don't want you to forget your questions, so you can submit your question at any time during the webinar. If you are having any technical difficulties or need to send me a message directly, you can reach me directly or any of our panelists through the chat bubble. That's the single speech bubble at the bottom of your screen. If you click on that, you can direct your message directly to who you need to speak to. But with that, I'm really excited to go ahead and pass it on to David so he can go ahead and get started with today's webinar. Thank you, David.
Great. Hey, how you doing? Thanks, Emma Jane. Really appreciate the nice introduction. Fox Blocks, our company, Airlite Plastics Company, Fox Blocks, and True Grid. Very humbled, very happy to be on this webinar here today, the week before Thanksgiving. So thanks for everyone for tuning in. This is a brand new presentation that my technical team has put together at Fox Blocks. And it's about resiliency and sustainability. You know, we've had quite a tear of tornadoes and hurricanes and wildfires and, you know, these catastrophic events that have hit us here in North America. Our product, Fox Blocks ICFs, we have had projects involved in all those events, tornadoes and hurricanes recently. We've been able to get out to our project sites and visit with our contractors and owners, and we have had projects that have survived these catastrophic events, F4 tornadoes, Category 4 hurricanes. And so we wanted to take this moment to update resiliency, sustainability presentation for everyone in our network and builders partnerships specifically. We have been part of this network for a number of years, training and educating its members on building with concrete, vertical concrete walls using insulated concrete forms with Fox Blocks. And so this presentation, I'm going to share about 45 slides, go through some of the key elements of consideration for using vertical concrete forms, its attributes, how we do it, the reason why we do it, and how we are not only meeting but exceeding building codes across North America. So sit back and relax. I have 45 slides. I am going to leave 10 to 15 minutes at the end of the webinar for Q&A. So please jot down any notes you have. And like Emma Jane said, if you want to put within the chat questions you have as we go, we're going to address all those. So let's go and get started. So I'm David Morris. So I'm a regional advisor for Fox Blocks. I manage the U.S. Southeast. I do have coastal areas within my region from the Carolinas, Georgia, Florida, Alabama, Louisiana, cover those areas, and the interior up into Kentucky, Tennessee, and surrounding states. And I am seeing a significant amount of high wind events in my region alone. Been in the industry for 15 years, was part of a team 15 years ago with military, schools, hotels, churches, massive commercial construction projects using insulated concrete forms. And now I specifically manage the U.S. Southeast for residential and light commercial construction. So our team has put together information primarily on the side of residential, but there will be very good technical information on commercial projects as well. We hope that you find this information impactful. We are here to be of service in part of the Builders Partnerships program. And so let's go ahead and move forward here. Our purpose of this webinar today, we're really going to go through and address some of the serious and significant weather events that's been hitting North America over time and most recently as well. It's devastating our homes. It's very serious from safety and from the side of rebuild. And, how do we address this in our communities? How do we build more resilient, strong homes and buildings that can withstand what Mother Nature throws at us? That's what we're really diving in here to today. We have a building solution that will check the box, for those needs and provide a lot more efficiencies, energy efficiencies, and lower operational cost on your buildings using our technology. So let's go through this part of resiliency and disaster proof. So we're going to go through the climate conditions, the impact of what happens with these elements when they hit residential and commercial projects. What are the impacts to these projects? What are the key considerations for future construction? How we can build better. We are going to give you an overview of insulated concrete forms, our product being Fox Blocks, ICF, insulated concrete forms, and then how we can better address weather events for the future from an insurance perspective, from a perspective of building projects will last multi-generations, no matter what Mother Nature can throw at us, okay? The changing climate conditions, really significant. Seeing a lot of tornadoes. I'm based in Louisville, Kentucky. We had a massive storm, massive tornado come through Southwest Kentucky, devastated a town called Mayfield, Kentucky. We have partners with Samaritan's Purse, similar to Habitat for Humanity, that have been helping the community rebuild, and they're using Fox Blocks for their structures and safe rooms on their projects to withstand tornadoes. Our goal is to really go through and look at resiliency construction for now into the future. Okay. The changing climate conditions, these are the key items that we're addressing here. What's changing in North America for us? The heat wave aspect, my colleagues that manage out west, we have areas where we get significant heat waves and just a tremendous amount of just high temperature. How do we address that? How do we look to reduce the energy consumption? How do we look to take down those peak hours of air conditioning and not only make sure that people are safe and cool, but to reduce that heavy use, on our electrical grid? We're going to address that. Cold waves for my colleagues that are up north, born and raised in Michigan. I know cold weather. We have colleagues, customers, and everyone works in Canada to the north. We're getting the snow flying already here before the U.S. Thanksgiving market. And so how do we address, being better suited for cold weather conditions? So the cold waves, okay, drought and fire. My colleagues out in California, and, happens out in the forest there, and, these wildfires that hit the communities and neighborhoods that are, close nearby or adjacent to, how do we build projects that are better suited for areas that might have, wildfire? How can you protect yourself? How to make sure that you have insurance on your properties, not only for wildfires, but tornadoes and hurricanes, to be fully insured, for the projects that you build. We can touch on that. Floods in my area in Florida, coastal areas from the Keys and Miami and, southwestern Florida that got hit recently with Hurricane Ian. How can we build projects that can withstand the flood and the storm surge that comes in? It's very typical on our coastal properties to have 10 to 12 foot piles that projects are built on top of, okay, to manage a 6 to 10 foot wall of water that can come through, in a tropical rain or hurricane event, okay. High wind, it can devastate. A property I have in northern Michigan. We had a tornado up there in Gaylord, Michigan, and it wasn't picky or choosy about what building it took down, what roof it tore off. But we have a lot of ICF projects up there that withstood that. And so key elements, this is what we're battling. This will be naturally occurring. How do we, with our intelligence and technology, build better, build better now for safety and for future generations. That's what we're touching on here. Heat waves, within these projects here, southern regions literally can get in a matter of weeks in the summer, can go through major drought and heat waves, okay? Can have blackouts, brownouts, major taxation on the electrical grid when we're using, peak energy. And that is just a very, very dangerous situation, especially for folks that retired and in retirement homes and relying on air conditioning to stay not only just cool but to stay safe. Okay, that way that they're able to be protected and not get hit with so much high heat. Okay, heat waves are addressed when we have good ventilation, good air conditioning, and we really introduce a good R value wall. And we firmly believe in concrete walls and really good continuous closed cell insulation. Okay, that can be accomplished with a variety of building systems. But when you look to really heavily insulate a conventional wall, cost of construction can go quite high, significantly high. With our insulated concrete forms, we're able to keep those costs relatively low because it's one form checking the box for a mass wall and double insulation. So we fare well in heat waves. Okay, cold waves, it's very common in northern states and provinces in Canada. High wind event, trees, taking down electricity. That is a resource that everyone needs to have a nice, warm, safe home and not have freezing pipes and not have the issues that come with significant, cold waves. And so, how do we address that? How do we put in better building materials to address it when your power goes off? Percentage of people are fortunate to have backup generators. But how do we build a better structure so that when the power goes off and it's off for, say, 12 hours, 24 hours, 36 hours, can we have a building product that can survive and keep your interior climate at a comfortable range and where you're not in jeopardy of freezing pipes without having a generator? Okay, it's a luxury for a lot of people to have the generator, but we have technology that can help you make it through that storm and to get the electricity back on if it goes out with insulated concrete forms. Okay, the drought and fire aspect of this, we hear all the time about what's happening, rainfall, rainfall issues and spotty rain, where we end up getting to drought conditions and we get into the wildfires. Those two come hand in hand. You get a drought situation, you get high winds, you have flame spread that can happen across areas, and so how do you have a building that's protected? Concrete, one of the best elements that you can use for that. So then moving in there for the floods, if we just keep getting hit, these storms that come in, the tidal surge that comes in from the Gulf of Mexico, comes in from the ocean on the Atlantic, significant. You have that type of storm come in, it's not uncommon to have 3, 4, 5, 6+ foot of water that can infiltrate. And it's not typically like a tsunami, it just comes in, it comes in over time, over a matter of hours, and water finds the path of least resistance, major devastation. Folks that are on the call here, I'm sure you've seen the recent video of Hurricane Ian down in Fort Myers. It was just so sad to see the marina, all those really large, massive boats that were tossed and turned and put right into the downtown area of Fort Myers. What storm surge can do, and that was unfortunately 8 to 10 foot wall of water that comes in. We also have a lot of moisture that makes its way in a flood event into homes, and so we're going to discuss what happens when that water infiltrates your home or your business, that wicking effect of moisture on lumber, how that penetrates and how it remains in the structure, and so it becomes an unhealthy structure. How can we put building materials in that will resist that and will not mold or mildew or create an unhealthy situation? So we need to address these items in here. Okay, the high winds, some of the most devastating and for loss of life. I see the tornadoes that come in, and the flying debris that's from these storms is significant. You have a project or a roof that comes up or walls that go down, creates a lot of debris and a lot of 2x4s and 2x6s that become impacts. They come flying around within those neighborhoods. And so we have a video in our presentation here that shows the impacts, in testing from 2x4s and 2x6s, what really happens in wood frame structures versus concrete structures, how to protect yourself from flying debris. Flying debris aspect is the deadliest part of any hurricane or storm. What happens with all those building materials and products that are around our neighborhoods, what happens, to that in these high storms and how we can protect ourselves. Okay. This is an image on the left side from Hurricane Michael. So a handful of years ago, Panhandle of Florida, Mexico Beach, Panama City, they got hit the hardest. Okay, very high wind event, upwards of 150 miles an hour. And so the properties that I viewed when I visited Hurricane Michael those years ago, you could see stick-built homes that were up on 10-foot concrete piles to be able to survive storm surge. But those stick frame properties, from the shear and from the wind, end up either overturning or toppling or racking. And when those stick frame homes racked, just would come down like a stack of dominoes. Okay. And so what we see in these high wind events is that you just can't anticipate, those loads, put in on conventional built, structures. There's so many different brackets and connections and anchor points for stick frame. But when Mother Nature wants to say, we're bringing the shear wind and there's a weak point on that property, it's not going to survive. The uplift on the roof will go, and then the walls will rack and it'll come down. In the same area where we had, projects that on the stick frame that were completely obliterated, we had ICF homes, concrete homes, up on the same concrete piles, and those homes survived. They had no racking, cast in place concrete all the way up, and the storm surge was fine. With those properties, they survived because they're up on piles. Okay, so they have a fortified structure with concrete columns with the ICF above, concrete all the way up, and the right anchoring down to our concrete walls for the roof, and so it survived. Now, what I feel is very important too is inland. When you have storm surge, it will go 3,000 to 4,000 feet inland, and in this case of Hurricane Michael, it came in 4,000 feet off of the beach of Mexico City, and it hit more modest built homes of 2,000 to 2,400 square foot, and those homes in neighborhoods in Mexico Beach, all the stick frame homes were pushed right off of their masonry block foundations, and they were floating in the respective neighborhood. We had a home on Pineda in Mexico Beach that was all Fox blocks. It was on grade. It had a cast in place footer, and we had Fox blocks, concrete walls locked into the footer. It took a 6-foot wall of water, and it acted as a retaining wall. That same structure where the other stick-built homes were floating around the neighborhood, that home on Pineda stood strong and survived through Hurricane Michael. They had to replace the drywall and electrical where the water came in the home, but there's no mold or mildew. The other homes were complete losses. And so we're going to touch on that insurance aspect of a full scrap and rebuild versus drywall and electrical, significant. Okay, so the amount of money and losses that comes through on these homes is significant. Loss of life being more important. Okay, so we have the consideration of storm protection, and then what do we do, during the storm, and then afterwards, how do we rebuild? And so we work closely with the folks at Habitat and Samaritans, and we have guidebooks from FEMA on building and fortifying your home with either a safe room out of ICFs, or you're building perimeter out of ICFs to eliminate this type of racking and total loss with a stick-built project. Okay, this impact on insurance is significant. We all feel it. We feel it in our premiums. Premiums continue to go up, just like our energy costs. Energy cost and insurance and our taxes. Those are the items that will just keep going up in the future. But how do we really protect ourselves? How can we help to lower that impact on insurance? And really, we've seen it with building more fortified building perimeter so that the project is not a complete loss. I've seen it, that neighborhood in Pineda, the insurance claim for the Johnson home was $18,000, drywall and electrical. The pier houses that are built around the same time as Johnson's, $300,000 to $350,000 losses, homes that were just completely scrapped. So that affects us. It affects us with the carriers you have, from State Farm and Allstate and the big providers out there. They need to recoup those costs. And, when you're looking at these hurricanes and tornadoes that come in and the losses being in the billions, that all gets spread out and we all have to foot that bill. So, we need to build, better. Okay. Builders risk insurance as well, for the builders that are on the line, for our residential and commercial, construction. We see significant cost savings in talking with our partners that builders risk insurance and using concrete vertical walls, fully documented throughout the build process and into operations saves money, significant money. So it can reduce, everything with your builder's risk insurance. Essentially, 22 to 72% less for builder's risk in using vertical concrete. Okay, everything along with that. We've got some really good studies that we're going to follow up with you all on the line here from our partners with NRMCA and Build with Strength, powerhouse of a website that goes into really in depth and detail about about builders risk and cost and insurance savings. Okay, so here's a study on commercial construction here. Okay, on what we call mid-rise building. Okay, buildings multi-story. We do a lot of hotels. We do a lot of assisted condos. We do a lot of big mass projects, and so it's an economy of scale. On this project alone here for this mid-rise 4-story structure, okay, seeing the mass timber building, okay, over an 18-month period, the same comparison with the builder's insurance on this thing, the insurance for this owner, okay, at $28,000 versus the stick frame construction being $158,000 for significant commercial projects. So it's a lot of savings, okay, a lot of cost savings for insurance throughout the build and into operations. Okay, so how do we address these impacts? Okay, we've gone through all the different naturally occurring events that we get in North America. Okay, so how do we really look to address this? We're very intelligent people. We are in 2022 going to 2023. There are significant building technologies out there that can help us. Okay, new construction standards that we don't need to be fearful of. They've been proven for decades now, okay, and suitable for all climate zones, concrete being one of those, okay. We want to build structures that are not only sustainable, but we want that energy savings. We want them to be fire resistant and moisture resistant. Projects can take on a flood. You can have a mass rainfall, in your neighborhood, and you can have water buildup if your storm drains can't cover it. Water in your basements, water that come up, through the storm water drains. And so how do you, when that happens, how do we make it so that the recovery is nominal for cost and that you don't have, major issue that's going to stay inside of that project. Okay. Engineering wise, with concrete, everything with anchorage to concrete, building shear walls, building projects that are strong from lateral and shear, load, everything in these areas that have, these catastrophic tornadoes, hurricanes, and fires. How can we really build these structures to survive? Okay. And then code, we all see that code is changing across North America for the better, higher energy efficiency, better strength, better longevity and sustainability. So hats off to all our different, code bodies that are increasing code in the products that we put in our structures. From a builder standpoint, it does not need to be more expensive. An integrated design of better building technology is just cost shifting. Using the right products does not mean that it's going to cost more. And so that's what our team is here to do, is help you analyze your current, building details, wall section details, and get you ahead of the curve with building technology. It doesn't need to cost anymore. From an inspection standpoint, we're really winning. Code officials in these areas, very receptive to, steel reinforced concrete. They're getting more familiar with insulated concrete forms. They're not being fearful of it. They're seeing this just a form. You don't strip the form, and the structures, the concrete, and the steel reinforcement inside of it. So through decades of training and education from organizations like myself with Fox Blocks, Airlite, NRMCA, our Insulated Concrete Forms Manufacturing Association. We're educating people every day that we don't need to be fearful of new technology, okay? It's really not new, it's been around for decades, but we're making people more comfortable with what we do. Certifications, there are areas that there are insurance premium reductions, and if you get certification for fortified homes, different fortification standards, that there are premium reductions in insurance, even for the homeowner, of showing it's a fortified project. We have FEMA details, FEMA using more concrete and endorsing not only insulated concrete forms for homes, but for storm shelters, for community centers, areas that if there is a storm or tornado coming through, that people can take, get out from the storm and reach a safe building. FEMA endorses all that. We are working with realtors and working with appraisal companies and Fannie Mae within the new appraisal guidelines. There are green valuation tools within these appraisals that you can call out that you have a full concrete structure using insulated concrete forms. And so it's a higher, more valuable property because of what it's going to provide in the real world against storms. Okay, and to prove that, one, home can be insurable. Two, it's going to last a long time, multi-generation. Three, the amount of dollars that need to be put in a home that's built out of ICFs is very low impact versus a home that needs to be torn down in a catastrophic event. So these items come into play for the insurance premiums and coverage on our projects. Okay, now we address this with ICFs. So new construction standards for climate, sustainable, durable, fire resistant, moisture resistant. The engineering on this is outstanding. The prescriptive engineering tables that we have for ICFs, lo and behold, it's the same engineering requirements as cast in place walls. If someone's using a typical form and pour and strip, typical concrete formwork, engineering for steel inside of these concrete walls from a conventional formed wall and stripped versus ICF is the same, it's equivalent. Our product doesn't need any more steel reinforcement or engineering than a typical cast in place concrete wall. Our forms just make it very easy and simple to go vertical. That's the piece we want everyone to really understand. Here's a detail over on the right side showing very typical ICF wall assembly. And just kind of take a look at what we're dealing with here. We've got a really nice cast in place reinforced spread footer. We can take our insulated concrete forms right down to that footer. There'll be dowel rod that comes up out of that footer into the vertical wall. Our blocks stack right up. We buck out the openings. We have a variety of different roof anchor points to concrete to have that roof tie right in and attach to the concrete of the ICF. And you talk about one heck of a strong wall. That is the way to go. So a variety of applications we can be used for. We have full libraries. We have all of our product and wall assemblies all detailed, 3D Rivet, 2D CAD, everything's available. This is just a glimpse into the possibilities of what we have. The overview of our product, if you've never seen insulated concrete forms, it is really a fun product. I've been really humbled to be working with this technology for 15 years. I would say this is a third generation of the ICF, originally coming over from Europe, is a post and beam insulated concrete form to a flat wall design. This is the standard that we're using here in 2023, is a flat monolithic steel reinforced wall. That's what we're achieving here. So we see the terms of when people say styrofoam or insulation, the real key technical term is expanded polystyrene. That is the chemical makeup of the bead that's formed around our unit in our web ties, okay, that makes our forms, straights, corners, radius forms, brick ledge. We have such a tremendous amount of shapes that can form up any type of vertical wall. But the key attributes of this is we have continuous insulation with our interior and exterior panel on the system. As you see up in the upper right-hand corner, this is one of our standard Fox blocks corners. We have a short side, long side configuration. The panels on this expanded polystyrene, that's a closed cell foam. Okay, this is not the typical styrofoam that you get from a coffee cup. Okay, different chemical properties. We are fully approved for construction across North America. And also this product, the same expanded polystyrene is used in coolers that we make for Omaha steaks. So it has to be approved for food and beverage and also for construction. So we're dealing with a really nice high level expanded polystyrene. You'll see also on our blocks that we have a really long 2-inch interlock. This is an interlock that's really robust. It's fully reversible. So it's made so this corner can flip over from course to course and grab onto the straight side of your ICF wall. So that's what makes our product really significant and a leader in our industry, is this full reversibility using this interlock. For lack of a better term of how like a Lego locks together, we call it our Fox Blocks interlock. It's really significant, okay? So our expanded polystyrene bead is molded around these black web ties that are inside of our system. You'll see that these web ties also have these chairs on top. We call them rebar chairs. They're like little plastic fingers. So that makes it so you can snap in your rebar, your steel that's specified from the engineer right into the Fox blocks without using a wire tie. Okay, so this steel, per the construction schedule, per your steel schedule, say if you're 16 inches on center, going all the way up the wall, say we're dealing with a 7-course, 9'4" wall. We're going to have one section of steel, horizontal rod. If they call it a number 4 or number 5 bar, that's fine. We're going to snap that right into the Fox Blocks web tie that's right inside here, inside of our rebar chairs. That's going to hold that rebar right where it needs to be per construction schedule. Okay, fantastic. We're going to have our dowel rods that we showed in the previous slide coming up vertically. Okay, stacking all our blocks, and then top of wall, we're going to slide down the verticals that'll intersect with our horizontals and making a proper vertical and horizontal steel rebar grid within the concrete wall. Extremely strong, okay? And so our product being expanded polystyrene is really significant for storms. We talked about storm surge. We have hard driving rain. We have flooding. Our expanded polystyrene is made up so it will not absorb water. That's a significant part of our building envelope here, is that when we do have water come in contact with our product, we don't absorb. Okay, so that's fantastic. That product will not promote mold or mildew, any type of growth. It's inorganic, okay? The only thing that has to be done in a flood situation where water hits our forms and our product is the drywall needs to be replaced. That has paper on the drywall. So that needs to be taken off to get rid of any type of mold or mildew. But on the inside of that wall, expanded polystyrene closed cell will never propagate mold or mildew, okay? It literally will not. So it doesn't deteriorate over time. And we are UL certified across the board. We have all our testing reports, all of our different processes that we go through with our product, fully available to everyone to work with you. So we're very sound, very waterproof product here. More on the overview. This is significant. So this piece that we see in the lower right-hand corner, that's our web tie, okay? That's like the skeleton of our Fox Blocks unit. These are set 8 inches on center. You'll see that it has a really wide flange here on what I call, say, the outside, inside of the wall. You have studs that are molded into our Fox Blocks units. The foam is molded around our unit to make it extremely strong and so that it will hold its shape during concrete placement. There's a lot of head pressure coming out of the pumps while we place concrete. So we had to make one heck of a strong web tie. Past years, we're talking, say, 25, 30 years ago, these web ties were not available in the market. So our company, Airlite Plastics, we had re-engineered and we had made one of the most strongest web ties in the market. To that point, we actually make web ties for other ICF manufacturers and help other companies make their systems better and stronger. So we are a pioneer of making the best and strongest web tie on the market. So these are all molded in the block. In this straight block you see right here, we're gonna have 6 of our web ties molded inside that system with all that continuous insulation around it. What's significant, say we talk about the extreme heat and cold, is that we eliminate thermal bridging. Okay, so we have a mass steel reinforced concrete wall that's there, and we have our closed cell insulation. So Doesn't matter if it's true 0 degrees or if it's 120 degrees. What's going to happen is our closed cell insulation is going to protect that concrete, and it's going to dramatically slow down that exterior temperature from impacting the inside of your structure. We have no bridge points. We have closed cell insulation. Then we have one heck of a steel reinforced concrete wall that's going to stay at a relatively steady state. A lot of the projects that I see where homeowners can put in thermocouples, you can easily see with $25 to $30 a thermocouple in a standard test. You typically see in a hot weather situation that ICF concrete never gets above 80 degrees because it's just such mass wall and that continuous insulation that's on it. And so we think about that from a cooling and heating perspective. It changes the game. Having this mass wall on your project, dramatically slowing down thermal transfer and making occupant comfort so much better. Don't need the same tonnage, don't need the same BTUs within your projects, okay, because of this ICF wall, okay? So just some of those key attributes, giving just a brief overview on what our block looks like and the skeleton inside of our system being our web tie, fantastic system. Our system comes in a variety of different shapes and sizes based on the structural need. Okay, so there are areas where we have patio homes or slab on grades that are going up, say 9 to 10 foot. Typical to use a 4-inch concrete core. I mean, it's the size of my fist. So if someone's really looking to use our slimmest insulated concrete form, you can do 4-inch concrete core. What's typical in my region for residential projects is 6-inch concrete core. So with that double insulation on each side of 2 5/8 plus the concrete core, our block system is 11 1/4 inches for a 6-inch concrete core. Okay, can be slimmed down to 9 1/4 if you use a 4-inch concrete core, but we have to take a look at your design, have the structural engineer of record. We can work with them, send them our prescriptive engineering tables, and decide on what is the best concrete core for the use of your project. Okay, we do monster projects, 3, 4, 5 stories plus. We start getting in the realm of an 8-inch concrete core. Just depends on how you tie in your flooring as well. Okay, so that could be a technical discussion case by case on the projects you have, but typically in residential, 4, 6, and 8 for the concrete core size is what we use. Now, for our military jobs and for our projects that are exceeding 20 stories, we get into our 10-inch and 12-inch concrete core for the structural need, okay? The block size of its length for corners and for straights all stay the same, but our concrete core changes. Concrete core, all based on the structural need, but you're only limited with ICF based on creativity and imagination. The right structural engineer that's familiar with vertical concrete walls will be happy to see that our tables and our engineering is right in line with conventional concrete construction. We just don't strip off our insulation. I get this question all the time when I do trainings, and I get someone at the end of the training saying, well, hey, great forming system, but when do you take off the form? Yeah, I kind of give a little smile. I'm like, well, that's your continuous insulation. This is not a form and pour and strip. There's a tremendous amount of speed of construction because we're putting in double insulation as the form and we're not stripping it. So it's just it's a shift in the construction process for the better for all the builders on the line for speed of construction. Okay, look at this product line. We have the most robust product line that's out there in the market. I talked about our corners, I talked about our straights, but we have T-block, we have curb block, we have radius, we have bucks, all in different shapes and sizes that I mentioned before. We even have a knockdown system called compact. If we have projects that need to exceed 12 inches of concrete, we can use our compact product and expand that concrete core. We did some recent work for the US military where they needed a 32-inch wide insulated concrete form. They used our compact system to achieve almost a 3-foot wide concrete wall. So you're only limited by your imagination and what your product need is. Just want to go on the record that we don't have to over-engineer the projects to get extremely strong and energy efficient. We're here to help you. Myself and the regionals and our technical team, we can go through project and the needs of it and help dial things in for you with all this product line that we have. So you're not limited to just straights and corners or having to do a lot of miter cuts. to get to the angles you need. We have a vast array of product line for everyone to use, okay? Now we call it the Fox Blocks insulated concrete forms that we are a 6-in-1 wall assembly. And so I get builders that ask on the regular, well, 6-in-1, what does that really mean? Well, we're really checking the box for the building materials that you typically have on the job site. If you picture a laydown pile, let's picture that we're building a 2x6 frame wall. Well, comparing 2x6 frame to ICF, in order to give it a full comparison, full fair comparison, we have to also look at that laydown pile and put down the air vapor barriers. We have to put on the insulation. We have to put on a myriad of materials onto a conventional structure to check the box for structure, insulation, air vapor, all these different components. Best thing about the insulated concrete form is we're giving 6 wall elements with 1 block and 1 contractor. So instead of having multiple contractors keep touching the wall, putting on new materials to get it energy efficient and watertight, we're doing that with 1 system with our block. We're getting structure, continuous insulation, air barrier, water barrier, vapor, our attachment points, because we don't have to fur out our system. We have our studs 8 inches on center, and then we have our reversible interlock. So we really look at the critical path on construction projects. We can take 1 contractor and check the box for all these building materials and these techniques with 1 block. It's significant. Really take a look at the speed that we need to move in. And we also have a diminished labor out in the market. You know, we're training a lot of younger builders. We're training a lot of folks on our technology, but we sure could use a lot more hands, a lot more construction professionals. This product, it goes in line with maximum production, okay? And it's very easy on the body too. Our product is lightweight and you can get a lot more output with lower sprains and injuries and just less wear and tear on the human body. So ICFs have a lot going for it for these advantages, okay? Onto our resiliency side of it. Here we just have 2 contractors. It's a concrete pour day. They're placing concrete in our forms. You can see that we have bracing on the wall, 6 foot on center. We're placing concrete into the wall, and we have a guy who's vibrating the concrete, which is typical, using a 3/4 inch pencil vibrator. So 6-inch, 8-inch concrete core, typical for residential. The number 4 to number 5 rebar that's inside of it. And so essentially this is just a visual of our contractors placing concrete into our vertical walls. Just another day at the office for these guys. They've gone through our training programs, working with our product, and just once you get into it, the learning curve is very short and just take right to it, okay? Comparable to doing a full, stick build house, tying in everything on the stick build, being the structure, plywood, getting your roof trusses in, having all those elements in to make sure that you've got a strong project as you build throughout, can be challenging, okay? Say if you're in the middle of your construction process, you've got your walls up, you're getting your roof trusses on, but here comes a tornado or high wind. That could really impact that build, okay? When concrete's placed inside of our forms and we have our vertical wall up, those walls are not going to come down in a high wind event, tornado or hurricane during the building process. We don't have to have the roof trusses on for the concrete wall to survive that. So just I've seen projects, being built, shear winds, 70, 80 mile an hour winds, topple a stick frame build. ICF won't come down. Okay, so these attributes of how we're compared to wood. Concrete compared to wood is just two different discussions here. Vertical concrete being so strong, we want to put the wood inside of the projects. Where we have these storm events, and we want to protect the structure. ICF perfect for the exterior, and we can do stick frame on the inside of the projects. Okay. Next slide. Into the thermal comfort. Okay, so we have a variety of different tests show from extreme cold and extreme heat about how we really keep that interior climate, optimized, for the occupant. And so what we find, we have different thermal performance tests from stick frame to concrete. We see a dramatic slowdown of that going through the system. we get the question from people, hey, so what is an insulated concrete form for our value? Okay, so we are 2 5/8 on both sides. And when you add that up, that gets to an R23. Okay, but that's just from an R value perspective. That's not taking consideration the concrete mass, the thermal mass inside of it. My technical team calling out that we have what's called a heat battery. Okay, so when you have a complete building envelope that's encapsulated in concrete and the double insulation, you're really doing your best to keep the projects cool with air conditioning and keep them warm when you're putting heat in the structure. Okay, so great stuff. I'm going to be sending out links into our thermal performance testing and information that we have from Build with Strength program, but we fare extremely well with hot and cold climates with the insulated concrete form. Okay, we even have our U value calculations. We have a lot of different metrics that we can give off to the HVAC, heating and cooling folks. They just don't want to plug in R23. That's only one side, one element that they have to put in their dynamic calculator. They want to put in a no air infiltration, since we have full concrete up and we don't have air infiltration coming through. We want to put down that we are permeating less than 0.1 for permeance. So we do breathe slightly, but we don't need the air vapor barrier. The closed insulation, the closed cell foam on our product makes our walls breathe slightly, but we keep the air infiltration out. Okay, they want to put in the mass amount of concrete inside of the wall as well. Okay, on a 6-inch concrete core Fox blocks with steel, you're looking at 80 pounds per square foot of our wall, a significant, strong mass wall. Okay, so we have data we can give off to the heating and cooling guys to make sure that they get the tonnage right for air conditioning and to get the BTU consumption for heating just right as well. Per the zone in North America, just work with each one of our regional managers to get that dialed in for you. We are a very tight building envelope, but we're not, it's not so tight where we have like a sweaty project. We get the question from people like, well, am I going to have sweaty windows? Is this project going to breathe right? And the answer is yes. It breathes very well. What's happening is we're controlling the outside air infiltrating in through the home. And also you feel through like your electric boxes when you're doing some work that you have a draft, coming in, from that box. Well, that's the air infiltration within your stick frame walls. You don't have that in insulated concrete forms. Okay, so we are very, very sound, very good building envelope, but not too tight. Okay, so we have a separate study that we'll send to you on how to properly, heat and cool and bringing in fresh air into your projects. But the ICF envelope is not too tight. It's just right. Okay, fire ratings. This is really significant, especially in our projects that are multifamily. I showed the slide a little ways ago that was for T blocks. Okay, our T blocks can be used as those party walls in between multifamily, for multi-story and for duplexes and for projects modest to high end. Using the insulated concrete form, 6-inch concrete core will get you a 3-hour fire rating. That's really big in a lot of areas that have that issue with fire, and when you have multi-story, folks that are living in it. 4 inches 2 hours, 8 inches 4 hours. So we can have designed into your project the right fire rating for your project. One of the best parts about the insulated concrete form too is if there is a fire in a room, say in a bedroom that there's a fire, it's isolated, it's put out, say carpet or the flooring is burned, the drywall is burned. Once that's put out, you basically remove those elements. And even if the expanded polystyrene was burned, you just have to cut that off, remove it, put new insulation, new drywall, new finishes, but that wall is not coming down. Okay, it is a 3-hour fire rated wall. It's meant to withstand that heat, and you're not going to have any type of structural integrity issues on that project. Same type of fire in a stick built house, gets into that room, gets into the wall assembly, gets into the structure, you've got a major issue. Okay, so you've got some major construction considerations on fire within stick built projects. So that's where concrete and insulated concrete forms can really work a lot better, in those projects. Okay, all our different testing, fire resistance standards. We have testing code approvals that meet and exceed all the current standards across. And so in a follow-up document I'll give to everyone, based on the region where you work in, we have the applicable reports that will back you up. Okay, so exterior walls, interior, partition walls, in between occupants, corridor walls, and safe rooms. We're all tested and approved for that for fire. Here's a video I'll show you guys here about our fire ratings here.
The entire town burned. We lost an entire town. People lost everything.
And I still see wood construction being built now. That makes me pause.
And the great thing about this project is we're dealing with insulated concrete forms. This is a new technique for us, but ultimately we need to build the safest houses that we can. And this ICF technique is a way for us to do that.
I'm Greg Lewis, Executive Vice President with the National Ready Mix Concrete Association. We're here in Paradise, California, because the concrete industry is partnering alongside Habitat for Humanity International to build 50 concrete Habitat for Humanity homes in 50 states over the next 5 years. And the first ones are here in Paradise.
It takes every single partner as a whole to make this successful. And the fact that the National Ready Mix Concrete Association was able to supply all these donations, supply the expertise to teach us how to do this, has been a critical component of our success in these builds.
One of the things that we kept seeing on TV was the devastation from tornadoes, from hurricanes, from wildfires like here. All these natural disasters that just were erasing communities off the face of the earth. And we kind of said, we ought to have some sort of a strategy about how to help that. Well, this is one of them. The partnership we have with Habitat is something special. Hard left.
When you see this site, people instantly see a white foam block and they think styrofoam. Well, that couldn't be further from the truth. EPS foam is actually a 100% recycled material, and the post-construction material can also be recycled as well.
It's very volunteer-friendly way to build. A lot of folks refer to it as being akin to stacking Legos. It's a slightly more complex than that.
Ever since we started talking about this, I've been trying to picture what it looks like in real life, and it is just about exactly what I thought it would be. It's like a big Lego project.
Put a Lego on a Lego on a Lego on a Lego, and then concrete, Lego, Lego, Lego.
When Habitat first told me about ICF, I went on to their website just to kind of research it a little bit because I'd never heard of it. And the more I read about it, I was like getting so excited. That is life-changing, because that is security, I mean, that feels like a little bit sense of just safety.
I think there's going to be a lot of sweat and tears throughout this field because it really it's a pretty monumental step for these folks. They were renters beforehand, and they were bounced all over the place after the campfire, and now they're actually going to have a home.
There's nothing more that warms your heart
but also puts terror in you that this is going to happen again, unfortunately. We're going to have another paradise, and we need to be prepared, and we need to be building with resilient construction materials.
Everything around them is what their past held. This is about their future. I feel really pleased that the NRMCA is part of that.
So good stuff. You know, we always say that, you know, picture's worth 1,000 words, but the videos and the testimonials that we get from our partners, you know, out in the industry, you know, it's really helping to, it supports the hard work that we put in. We can really, you know, change communities and change lives, you know, with our products. So love that video, love all the work. I see my colleague, Mike Dalzell, was part of that. Hats off to the people that Build with Strength, part of the NRMCA. Like I said, wealth of information that we're provide to you guys. These are just the first steps. So let's continue. I have about 7 more slides and then we're going to get into Q&A. So stick with me. We're getting to the end here. So from a multifamily perspective, fire rated wall assemblies, architects and design firms, that is one of the key terms talking to designers. How do we get fire rated assemblies? How do we make this happen? How do we make it so strong, energy efficient and fire rated? And we're accomplishing this. Here's just, you know, some case studies, you know, in on this and what can be achieved from ICF. And look at the finishes too. Brick, stucco, hardy board, everything is applicable, you know, to our product. So we're not just a concrete box, okay? So everything within our design system, you know, for ACI, American Concrete Institute, we work with them. All our testing and technical code is so above board and is to, you know, to global standards, international standards, you know, right here in the US and Canada. You know, we are really leading the way in making sure that these projects are around for multi-generation, okay? Our different reports from ICC, storm shelters, ICC 500, the FEMA P361 for community safe rooms, safe shelters. We've got that put together. If there is one key takeaway from everyone in the process here, great way to start, say even on one of your stick-built homes, is we can incorporate storm shelter inside of your project even too, for say a bathroom or master closet. We have details and technical that you can put a safe room inside of a traditional built structure. So we have details on that. That's a good way to get started and seeing how quick we stack and the efficiencies in using our product and help you grow, you know, to using it for the building envelope, for the perimeter. So, you know, we can start small and help you grow from there. Here's an interesting video of our flying debris test.
Firing a 15-pound 2x4 at more than 100 miles per hour, the speed at which it would be carried by a 250 mile per hour wind. A 250 mile per hour wind speed covers 99% of all tornadoes and 100% of all hurricanes.
3, 2, 1.
This is typical of traditional wall sections. There's simply not enough mass or hardness there to prevent perforation. So the missile simply perforated, went all the way through, and did considerable spalling on the backside. We saw in this masonry with the stud wall section, the missile perforate completely, despite the fact that the speed was only about 70 miles per hour. It would not take a severe tornado to carry a missile at 70 miles per hour.
3, 2, 1.
This wall section that used the 4-inch steel studs simply did not have sufficient mass or hardness to withstand the impact of the missile. The missile splintered only when it hit the back wall of the laboratory.
The first ICF wall has a 6-inch thick solid concrete core with a break veneer.
3, 2, 1.
Again, damage was confined to the vinyl siding and the foam beneath it. The concrete wall itself is unscathed. Another test on the other side of this wall confirms its solid performance. even at a missile speed of 120 miles per hour, there is no damage to the concrete wall. Researchers.
So I think everyone gets the gist of that test. Okay, so in a flying debris, tornado, hurricane, you've got miscellaneous materials that are flying around. And so within 16-inch on center, wood frame or steel stud cavity, flying missiles, construction debris, any elements can impact and come right through conventional built structures, but not with insulated concrete forms. That mass concrete wall, you all see what happens when a 2x4 impacts it at that type of speed. It just splinters the wood and protects the occupants inside because of that monolithically poured wall. Okay, here are safe designs and even modest storm shelters, homes that are built out of ICF, how our product can go all the way down to the footer, all the way up the vertical wall and cast that all in place. Only limited by imagination and how our product can be used, to save lives. In flooding, what we have with our testing, that we not only meet and exceed ASCE 24 from flood damage and getting a house back up to its finished state, as I referenced before, drywall and Romex electrical having to be replaced, but not the structural wall, and not having to come in and take down any of the foam, the insulation, expanded polystyrene because of its makeup. Okay, and so essentially our product, what we have here versus wood, when wood frame comes in contact with flood, when it's underwater for 2 days, you have a 65% saturation. After 2 days to 4 days of it starting to dry out, you still have saturation of 25 to 35%, within that framed wall, and it continues to wick. So eventually it's going to bring mold and mildew, and the structure is not going to survive. And so, even in areas that are, more coastal and high humidity, that just makes the situation even worse. The homes in Mexico Beach impacted by the floods were completely rotted out, after a week. It's really, really something sad. So our resiliency in here and in the images that you see is where we had water submersion with a stick frame wood to ICF. Okay, and so what we're seeing here is that once we have full water submersion, okay, that we're basically reading a 20% water after the water has been up to the ICF. Okay, and then what happens is after 1 day of the water being taken away, that we basically our product, our EPS, dries to a 0% moisture versus the wood. The stud, even after 2 days, can still be at a 15 to 20% moisture factor on that. So it's just, when we can get that product away from floods and away from water, then that structure is going to survive. That construction product is going to survive. Okay, so we basically have gone through and we basically touch on how ICF, we address 4 key scientific properties of building home. We have air, moisture, vapor, and thermal transfer. Okay, so within conventional builds, we have to keep putting conventional materials on those structures to hit these properties. The ICF nips it in the bud with 1 block and 1 contractor. Okay, and we're getting so much more performance out of it. So it's like we have our block that's going to be available and resist anything that Mother Nature throws at us. And then from the day-to-day operations, we're getting all that energy savings, we're getting all that comfort, we're getting all those performance properties. So the block is working 365, 24/7, no matter what Mother Nature throws at it or what the normal living conditions are, to save energy costs and to increase comfort. Okay, I've gone over some of these key elements. I'm getting to almost the end of the slide deck here, just a few more visuals, and we'll get into Q&A, but we are going to stand the test of time. No matter what gets thrown at us, this ICF concrete wall will last. It'll be around for multi-generations. It's very simple to use. It's a sustainable product. In fact, our Airlite Plastics web ties, over 50% of the weight of our ICF form is a recycled plastic material. That's our web tie. Significant. We have recycled material inside of a product that's going to last hundreds of years. That's significant. We're strong, we're safe, fire rated, storm resistant, and then the whole value of it. Okay, so you have cost shifting on the construction side of it with speed of construction. 1 contractor doing the work of 3 or 4, And then on the owner side with lower heating and cooling bills. Okay, so all across the board, there are efficiencies. So I'm getting close to wrapping up. I always say our 6-in-1 wall assembly, we can't be beat. There's not another wall assembly out there with one block or one system that checks the box like insulated concrete forms. And so we transcend from the most modest basement, storm shelter, residential home, and multi-story mass projects. Our product works well across the board in all those project types. And then here's our commercial benefits of it. Okay, so we can go up and we can do gables, we can do multi-story, we can incorporate hollow core plank, cast in place floors, all these really neat things for commercial construction benefits as well. And in summary, what we say is that the long-term financial savings, occupancy, comfort, and safety, okay, and everything having to do with building performance, fire protection is way more important than first cost. And now we're at a point with first cost where we really break down all the elements that go on a conventional wall and compare it to an ICF. We are very close in cost, almost to the point it's a missed opportunity to use ICFs right now. If you're looking at conventional builds and looking to layer it to very good, fire rated standards and storm resistance, the elements you have to put into a conventional wall will quickly meet the cost of an ICF wall, and we're losing all that comfort and all that energy savings. And so it's a win across the board for contractors, builders, and occupants. We can all work together on this. And so we say that there's so many reasons to look at building with ICF. You have all of us, there are 12 of me across North America, full technical team, lots of design, build, and dealers and contractors very familiar with this. You're not the first using our product. And so we have a wealth of information to share openly with everyone that's on the call. And so I'm going to open this up now for Q&A. Just want to say we are just a few minutes over. I appreciate everyone staying on the line. We have a lot of good information to share, but let's go ahead and start with questions there, Emma Jane.
I don't have any questions listed at the moment, but I want to thank you so much for this presentation. It has been a wealth of information. I've watched a couple of your other presentations, and we did have somebody come visit one of our builder groups one time, but the way that you have this information prepared, I think it says a lot. I love the slide that you have where you talk about all the different elements that you can eliminate from the construction process to shorten that time of the construction process, and that the cost of building at this point, with the cycle times being so long and the interest of a lot of home builders right now bringing that cycle time into check, this is a great product to take advantage of and look and see if it fits into their model.
That's great. Yeah, that's a really important point, and we appreciate that. We share our costing and budgeting up front. Anyone who's interested in our product, we can go through and look at typical models and floor plans and line out a construction schedule and look for ways that we can speed up that process and take that critical path and schedule and make it very friendly for the builder, and then do the cost shifting. This is a big one. A lot of the heating and cooling professionals out there, and they're looking at the design of a home, and they're looking at square footage and the typical tonnage they need for air conditioning or BTUs for heating, and this changes everything. So we need to have better discussions, because those heating cooling professionals need to get in tune with this right sizing of mechanical equipment. We don't say downsizing, it's right sizing it. And we never posture of just shoot from the hip of saying, hey, you're going to save so much energy, but working with a heating cooling professional with the specific performance of our block can really move and save thousands of dollars in the heating and cooling, and put that to bridge that gap between a wood frame wall and ICF. And so these are elements in cost shifting in a well integrated and designed home is good for everyone. And then what happens is the builder has less callbacks. You don't have the same type of, well, I've had a real strong, heavy rain. I've got some leaking on a window. We're going to reduce the callbacks. We're going to eliminate a lot of that frustration on the owner end on their new home, and the builder having to come back and service a home. We're making it so that everyone can just keep moving on and build with speed and efficiency.
Oh, well, thank you so much. And Chuck has always been a proponent of your product. He loves the idea, loves the efficiencies of it, loves how it can improve cycle time. And now to hear how it helps with resiliency and sustainability, it's a great product. So I really hope that everybody has an opportunity to check it out and spend some time with you. Tomorrow, an email goes out with your email in there. So if anybody has any questions, they can contact David directly. And we look forward to seeing you at a future webinar Wednesday. And we have one scheduled for you for December 7th. So you'll be back with us for another one.
Yeah, early December, that'll be great. I'll look to add on a little bit more from Hurricane Ian, the projects that survived Hurricane Ian. They were built out of Fox blocks. Chuck, thank you. You're always so gracious in talking about our product, and we are educating every day. And what we just ask from our builders and our construction professionals is we can help you take a real serious look at the product. You don't have to be apprehensive or listen to people in the industry saying, well, hey, I'm not familiar with that, and so I'm just not using it. Well, the time for education's now. There's really great materials out here, and we've been doing this for so long that we can bridge that gap and be the conduit to have you incorporate in saying, hey, you have your typical models. Well, hey, here's the Foxified model that's fire and storm proof, and consumers are willing to pay just a modest few percent difference, and everyone wins because of the energy efficiency. So we really encourage everyone to reach out. There's no questions you can bring that are going to hurt our feelings. We want to know what you're building. We want to know what you're involved in, and we want to be a positive influence in helping you start to use product and help you grow with us. And so we're fully available to you guys, and we're a very optimistic member on your team and to help you understand it. So just appreciate the opportunity to educate everyone, and we're growing every day. So thank you.
Excellent. Well, thank you so much. And we look forward to seeing you again in December.
Sounds good. Great, guys. Have a happy Thanksgiving. Thanks for everyone for being on the line.
Thank you, David.
Much.